Okay, so we have basically, from the screen before, 5x cubed minus 13 halves x squared plus 5 halves x minus 7 divided by x minus 3 halves. That's what we got when we clean this up because it needs to be x minus something. You can't have anything in front. So I'm going to have 3 halves on the outside, 5, negative 13 halves, 5 halves, and negative 7. Okay, so let's do this. So bring down the 5. 3 halves times 5 gives me 15 halves. Negative 13 halves plus 15 halves gives me 2 halves, which is 1. 3 halves times 1 is 3 halves. 5 halves plus 3 halves is 8 halves. 8 halves is 4. Remember, you're adding. 3 halves times 4, so 3 halves times 4. 4 goes into, or 2 goes into 4 twice. That's going to give me 6. And when I add them, I get negative 1. So this is my remainder. This is my constant term. This is my x term. That's supposed to be a number. This is my x squared. So we get 5x squared plus x plus 4 minus a remainder of 1 over x, over x minus 3 halves. And if you want to clean this up even more so that it doesn't look like a fraction within a fraction, I could multiply the entire thing by 2 on top, 2 on bottom. That's going to give me 5x squared plus x, because if you remember, my original one was not x minus 3 halves, it was 2x minus 3. So you need to multiply to get back to what your original one was. And that is my division for this one. Okay, so the remainder theorem. Okay. If a polynomial f of x is divided by x minus c, kind of what we just did, the remainder is r equals f of c, and f of x equals x minus c times q of x plus r. So basically what that means is if my c is out here and my function is in here, then my remainder is down here, which is my f of c. So if we look at this division pattern, so for example, if we looked at 6, negative 25, a problem that we did a couple slides ago, 2, 6, negative 13, oops, wait, erase that, 12, negative 13, negative 26, negative 8, I probably wrote too big, 7. That means that 2, negative 7 is a point on your graph. It also means that that 2 is not a 0 on the graph. So in order to be a 0 on the graph means you get a remainder of 0. So a 0 means you get a remainder of 0, because a 0 is just an x-intercept, which means your y value is 0. Okay, the factor theorem says a polynomial f of x has a factor x minus c as long as the remainder is 0. So we just said that. So a factor basically means it will cross the x-axis at a certain point. So I want to know, is x minus 1 a factor of this function? So I'm just going to do synthetic division and see. This is going to help us factor things that are not as easy to do with our traditional factoring. So I've got 4, 21, 25, negative 5, 3. And if this is x minus 1, that means my 0 is 1. So I'm just going to do my synthetic division, bring down my 4, 1 times 4 is 4, 21 plus 4 is 25, 1 times 25 is 25. 25 plus 25 is 50. 1 times 50 is 50. Negative 5 plus 50 is 45. 1 times 45 is 45. 3 plus 45 is 48. You get a remainder of 48, so the answer is no, because it's not 0. If we look at example 2, okay, same numbers, I'm just trying a different one. So if this is x plus 3, that means you're going to use negative 3 on the outside of your synthetic division. Bring down my 4. Negative 3 times 4 is negative 12. 21 minus 12 is 9. Negative 3 times 9 is negative 27. 25 minus 27 is negative 2. Negative 3 times negative 2 is 6. Negative 5 plus 6 is 1. Negative 3 times 1 is negative 3. 3 minus 3 is 0. So this one is a factor. That means it crosses the x-axis at negative 3. Okay, let's take a look at this last one. Example 2x cubed minus x squared minus 41x minus 20. I want to tell you if, oops, hold on. Let me use the hand. Okay, so if x plus 4 and x minus 5 are factors, let's move this in. What are the remaining factors? So I'm already telling you that negative 4 and positive 5 are the two that I need to try. So I'm going to use synthetic division. 2, negative 1, negative 41, negative 20. And in case you're wondering where I got those, there's the 2, here's the negative 1, negative 41, negative 20. I'm not missing any terms, so I don't need to do 0. So I'm going to pick either one of these to start with, negative 4. So bring that down to 2, negative 8, negative 9, 36, negative 5, 20, 0. So I already know that if I told you these are factors, it should come out to be 0. Instead of trying 5 on the original, you're going to try 5 on the condensed one, not including the 0. So now I'm going to do 5 on here. That leaves me with 2, 10, 1, 5, 0. So what's left is this is your constant term. This is the coefficient for x. And so the remaining factor is 2x plus 1. So if I give you multiple factors at the beginning, you use those two factors and keep going on the condensed polynomial. Don't go back to the original or you're never going to get it down. Your goal is to take this and either get it down to a quadratic, or technically I could have factored it here, but since I already told you that 5 was one of them, break it down and you can figure out what the last remaining factor is in that equation. And that is the, oops, that is the end, 2.3.